Okay, this is a Bayes rule problem concerning if you actually know the answer to if you got the correct answer to a question, what is the chance that you actually knew the correct answer? Okay, so there's two possibilities. If you know the correct answer, or you do not know the correct answer. Now, if you know the correct answer, the chance of you getting it correct is 100%, and the chance of getting it incorrect is 0. Now, if you don't know the correct answer, then you guess. There are m possible answers to the question, of which one is correct, and so the chance of guessing correctly would be 1 over m. And the chance of guessing incorrectly would then be m minus 1 over m. Okay, the chance of knowing the question has probability p, and therefore the chance of not knowing the answer is 1 minus p. Okay, so let's figure this out. The question asks for what's the probability that if you have the correct answer that you actually knew the correct answer. So that's the probability of knowing the answer and getting it correct divided by the probability of getting it correct. The chance of knowing the correct answer and getting it correct would be just simply p times 1. So p times 1. The chance of getting the correct answer, well, there's two possibilities. It's this same branch, p times 1. And then there is a second branch, 1 minus p times 1 over m. And that's basically Bayes' rule, because the what's given over here, like this one here, let me switch colors, the one that's here, that is the probability of getting it correct, assuming that you know it. And this one here is the chance of getting it correct, assuming that you don't know it. And so here we're reversing the role of which thing comes first. So that's when Bayes' rule gets used, when the reversing the role of which event comes first and which event comes second. There is a big long formula for Bayes' rule. I recommend that you do not try to memorize the formula. I think it's a whole lot easier to draw out a tree diagram and then just simply use the rule for conditional probability. I think that's a lot safer way to do the problem. Alright, then we can simplify this slightly by multiplying top and bottom by m, and we get m times p over m times p plus 1 minus p. And that's pretty much as simple as this can become. Okay, then lastly the question asks to find the numerical answer if m is equal to 5 and p is equal to 1/2. So if m is equal to 5 and p equals 1/2, so it's a multiple choice test with 5 parts, A, B, C, D, E, and the student has a 50-50 shot of knowing the answer or just having to guess at the answer. Then it turns out the probability of k given c works out to be 5/6. So if the student gets the answer correct, the chance that the student actually knew the answer as opposed to guessed at the answer was 5/6.